Alright, you guys, let's start this Chapter 10 study guide. So, number 1 is a really long word problem. It says, when designing a building, you must be sure that the building can withstand hurricane force winds, which have a velocity of 74 miles per hour or more. The formula, alright, so now we have a formula, F equals 0.004 area times velocity squared, gives the force F in pounds exerted by a wind blowing against a flat surface. Well, A is the area of the surface in square feet, and V is the wind velocity in miles per hour. How much force is exerted by a wind blowing at 87 miles per hour, so here's how much it's blowing at, against the side of the building shown. So we already have the V, the velocity, it's 87. We need to figure out what A is, so we can determine how much force. So all we have to do is figure out the area below down here of this picture. So it's clear that we have a triangle on top, and we have some kind of parallelogram on bottom. So for the bottom, our area is base times height for the parallelogram. So 12.5 times 21. And our area for the triangle is 1/2 base, well, it's 21, times height, which is 6.2. So our area for the triangle is, when we do that math, 65.1. Put that in your calculator. And the area for the parallelogram is 262.5. So when we add those together, we get 327.6. Now I just need to plug this into my formula. So force F is equal to 0.004 times the area, 327.6, times the velocity, which is 87, and squared. And when we put that in our calculator, we get 9,918.4176. So that's our force. It says how much force exerted, and this is our force. But force is in pounds. So this is in pounds. We need to change this to tons because all of our answers say tons. This isn't a conversion factor that I expect you to know, so I'll give you this conversion factor on the test. And what we do is, for every 1 ton, that's equal to, for every 1 pound, that's equal to 0.0005 tons. So what I'm going to do here is multiply this number over here, multiply this by 0.0005, and then I'll have it in tons. So my final answer is 4 point something, I forget, 4 point blah blah blah, so it's about 5 tons. So our answer here is A, and like I said, I'm going to give you this conversion factor, so you don't have to worry about memorizing it. Alright, number 2, 3, and 4 is find the area. It tells us the figure is not drawn to scale. So for number 2, we have a parallelogram, and our area is simply base times height. So area equals base times height. Well, our base and our height, the height that's given is this height right here, and we can see it's perpendicular to this base. So that's the 2 I'm using. So the base on the bottom is 33, just like the base on top, and the height is 22. If you need to, go ahead and just, outline it like I did, and it might make it easier for you to realize what 2 you're using. When you do that math, your area is 726 inches squared. So there's our answer. Looking at the next one, we have a triangle. So here our area is equal to 1/2 base times height. So our area is equal to 1/2 6 times 10. Again, here's our height. So here's our base. It's perpendicular to that height. And when you do that math, we get 30 centimeters squared. Lastly, number 4. Okay, so we have an irregular shape here, but it's clear that we have a rectangle and then we have a triangle. So first we're going to find the area of the rectangle. So area equals base times height. And our base would be 9 and our height is 13. So area equals 9 times 13. And I get 117. And then the height, or the area for a triangle, area equals 1/2 base times height. And my base here is 11. And my height is right here. Well, if this much is 8, and this whole thing is 13, then when I subtract them, 13 minus 8, I get this part to be 5. So area is equal to 1/2 base 11 times height 5, and I get, put that in your calculator, you get 27.5. So now if you just add these two together, because this is your area of your rectangle, here's your area of your triangle, you add it together and you get your answer of 144.5 centimeters squared. So here's our answer. Alright, number 5 says, what is the height h of the parallelogram? Well, we know area is equal to base times height. So if we look here, here's a height, and it's perpendicular to this base. So we see that 24, the height perpendicular to 36. So that's one formula that could give us area. I didn't mean to draw down here. So is, if we outline another one, we see that here's a height, h, and it's perpendicular to this base, 27. So we can say that these are equal to each other. So 27 times h. And now we just solve. So we solve for h, so we say 24 times 36, and we get 864 is equal to 27h. And to solve for h, we divide both sides by 27. So h is equal to 32. And we don't have any units here, so just 32. Number 6 says, find the area of an equilateral triangle with a side of 10. So we can do this a few different ways. Let's draw our triangle out first. Awesome. So here's my equilateral triangle. My sides are 10. I know for a triangle you need to figure out the height. So if you draw this coming down, your height, your altitude, well, this altitude, it's going to bisect these two sides here. And we don't know that because of the definition of altitude. We actually, if we were to draw our center of the triangle and we were to draw our radii, then you can see that this altitude also acts as our apothem, really. And we know the apothem cuts the side equally in half. So we know that these two sides really, down below, is 5 and 5. So now I can go and find my height. Well, again, we can do this a few different ways. To find the height, and again, we want to find this whole height right here. Let me get that a little bit darker. We see that we have a 90-degree triangle that we created. And so we could go ahead and use the Pythagorean theorem. To find the height, we could say 5 squared plus, we can call this x over here, x squared equals 10 squared. So we got 25 plus x squared is equal to 100. Subtract 25, so x squared is equal to 75, and then take the square root on both sides. And when we take the square root, we get x is equal to, and we square root both of these, well, when you square root 75, it breaks down And we'll break it down over here. 2 doesn't go into 75, but 3 does 25 times. And then 5 goes into 25 5 times, and 5 goes into 5 1 time. So we have a pair of 5s. So 5 comes out, and that 3 stays in. So there's our height. So now we can say that the area, is equal to 1/2 the base, and we want the whole base. So here's our whole base. So 10 times our height, which was 5 square roots of 3. And when we do that math, we get area is equal, well, half of 10 is 5, 5 times 5 is 25, so we get 25 square roots of 3. Again, though, this was just one way you could have solved this. You could have found the apothem here and the central angle, or you could have found the apothem and then doubled that for the height. You could have done a lot of different things. You could have used trig. You could have used the sine function for trig and used the angle of 60 degrees. Again, you could have just done 6 a lot of different ways. So if you got the answer 25 square roots of 3 and you didn't do it my way, that's okay. Like I said, you could have done it a lot of different ways. Alright, number 7 and 8 and 9 says find the area of the trapezoid. Leave your answer in simplest radical form. I left out the t here. Simplest t radical form. Okay, so for number 7 we have a trapezoid, and we know the area is equal to 1/2 the height times base 1 plus base 2. And we're not given both of our bases. Here's one base, here's our height. We need to figure out the base below. Well, since this is 9 and these lines are perpendicular, I know this is 9 also. And then since this angle is 45, and this is also a right angle, that makes this angle up here 45. And I know you probably can't see too well in yellow, so let me erase that and rewrite it. That means this angle right here is also 45. And so even though it doesn't look like it, we actually have an isosceles triangle. This triangle right here is isosceles because it's 45, 45, 90. So we know that the legs are congruent. So if this is 5, then this is 5 down here. So now I know base 2. It's 5 plus 9 plus 8. So the base below, 14 plus 8 is 22. So I'm just going to plug all that in. So area equals 1/2 height, 5, base 1, 9, plus base 2, 22. I'm just going to throw all that into my calculator, and I get, one moment, get 77.5 centimeters squared. So here's our answer. Alright, looking at number 8, this gives us everything. Here's a base, here's a base, here's a height. We know this is a height because it's the 90-degree angle right here. So we can just plug all this in. Area equals 1/2 height, 7 times base 1, 8, plus base 2, 12. So again, just throw all that into your calculator, and you get, where's my answer here? We get 70 inches squared. Alright, and now let's look at number 9. Number 9, and this is the reason, number 9 is the reason for these directions up here of leave your answer in simplest radical form because of problem number 9. So directions again on your test are probably going to be similar, leaving in simplest radical form. So I'm going to show this using the 30, 60, 90s triangle. So let's find a new color to write with. Okay, so again, we know what our formula is. Area equals 1/2 height times base 1 plus base 2. We need to know our height. We don't have that over here, so we need to figure out the height. And we need to figure out our base 1, and we need to figure out our, oh nope, we have our base 2. We have 13. Alright, so what's given though is this leg over here of 6 feet. And we know that this is a 60-degree triangle, so that makes this 90, and that makes this up here 30 degrees. So that's really helpful. because we know that the hypotenuse is equal to twice the short leg. So hypotenuse is equal to 2 times the short leg. So if the hypotenuse is 6, then to solve for the short leg, I'm going to divide both sides by 2. So the short leg is equal to 3. So I know right here, then, that this is 3. And if I know that, and I know the whole thing's 13, then I know my base 1 up top is 13 minus 3, which is 10. So now I know both bases. I also know that the long leg is equal to the short leg times the square root of 3. So the long leg then is equal, since the short leg is 3, then it's 3 square roots of 3. So now I know what my height is. So this is my height, 3 square roots of 3. Because again, I'm thinking of the 30, 60, 90 triangle and the special right triangles. So this is 60 and this is 30. Then here's our side. This is 2 times the side, and this is the side square roots of 3. That's what I'm thinking to come up with all of this. Let me circle that up, or box it in. So now I have everything that I need. I have base 1, I have base 2, and now this is my height. And I'm just going to plug all this in. So area is equal to half the height, 3 square roots of 3, times base 1, 10, plus base 2, 13. Alright, so area is equal to 1/2, 3 square roots of 3, 10 plus 13 is 23. So area is equal to, say, 1/2 times 3 times 23, and I get 34.5 times the square root of 3, and this is all feet squared. It says on your answer key 69 divided by 2 square roots of 3, and that's the same thing. You get 34.5. So here's our answer for this problem. Notice if you would have used one of your trig functions like sine, or, well, in this problem to find the height, you would have used this angle, and you would have used sine, so opposite over hypotenuse, and you would have had the trig function there, and you wouldn't have been able to leave it in simplest radical form. So that's why it's important to know your 60 right triangle, 60, 30, 90 special right triangles. This is another thing that I'll make sure I put on the board too. Alright, number 10. Number 10 says, what is the area of the kite? Well, we know the formula for the area of a kite is 1/2 times diagonal 1 times diagonal 2. Diagonal 1 we see is just 8 plus 16. So I can say area equals 1/2, 8 plus 16 for diagonal 1. And diagonal 2 we have 5 and 5, so 5 plus 5. And then I can plug all this into my calculator too. I can say 1/2 times 24 times 10, and I get that my area is equal to 120 feet squared. Number 11 says find the area of the rhombus. Well, the area of the rhombus is the same formula. Area equals 1/2 diagonal 1 times diagonal 2. We see here that we have all the half lengths, so we can just figure out that diagonal 1 is 6 plus 6, which is 12, and diagonal 2 is 6 plus 6, which again is 12. So our area here is half of 144, so our area is 72. Oops. No. So our area here is 72. Let me write that better. 72 meters squared. Alright, number 12 says, given the regular hexagon, find the measure of each numbered angle. Alright, so since it's a hexagon, we're going to say 360 divided by 6. And that's going to give us the measure of angle 1. So measure of angle 1 here, we see we have all these radii drawn. So therefore this is the center. So therefore angle 1 is a central angle. So 360 divided by 6 is 60 degrees is the measure of angle 1. Hold on a second. My cat. Go on, Harry. Alright. measure of angle 2 we see below is created by drawing the apothem, and the apothem just bisects the central angle. So the measure of angle 2 is 60 divided by 2 is what our measure of angle 2 is. So 30 degrees is equal to our measure of angle 2. So far we have measure of angle 1, 60, measure of angle 2 is 30. Well, the measure of angle 3 is up here in this corner, and again, we could draw the apothem, and again, our apothem we said was 30 degrees. We have this 90-degree angle down here, and then we have this triangle here now, and we know a triangle adds up to 180 degrees, so we can just say that the measure of angle 3 plus 30 plus the 90 is equal to 180, and we can solve. So measure of angle 3 plus 120 is equal to 180, and when we subtract 120, then we see that the measure of angle 3 is equal to 60 degrees. So there's our last answer. Let's look at number 13. Alright, number 13 says find the area of a regular hexagon. So area of a regular shape is A equals 1/2 the apothem times the perimeter. Now it tells us we have an apothem of 14.7, so I can plug that in. Area equals 1/2 14.7, and now I just need to find my perimeter. Well, it does tell us that we have a side of 17 centimeters long. For a hexagon, there's 6 sides, so my perimeter is equal to 6 times 17. And when I multiply that out, I find that my perimeter is equal to 102. So when I plug that in to my formula, I just need to put this in my calculator. 14.7 times 102 times 1/2. And I find that my area is equal to 749.7 centimeters squared. So here's my answer. Alright, number 14 says you're planning to use a ceramic tile design in your new bathroom. The tiles are blue and white equilateral triangles. Blue and white equilateral triangles. You decide to arrange the blue tiles in a hexagonal shape as shown. If the side of each tile measures 7 centimeters, what will be the exact area of each hexagonal shape? Okay, so we know the side is 7. We know these are equilateral triangles, so we know this is 60, and this is 60, and up here that's 62, because they're all equilateral triangles. Well, to find the exact area of each hexagonal shape, we're going to use the formula A equals 1/2 AP. Now, we know that the perimeter is 7 times 6. Since the side is 7, then there's 6 sides. So our perimeter is equal to 42. So I just need to find the apothem. So if I draw, let's see if I can erase here. If I erase this, and I draw my apothem coming down here, then now this angle right here is half of 60, so that's just 30. And I can use a function to define what my apothem is. Well, if you recall your special right triangles, we draw our special right triangle right here. I know that if this is 30 up here, then this is my short side. And my short side's half of 7, so this is 3.5. I know my hypotenuse is twice my short side, and I don't care about that, that's the radius. What I want to find is the apothem right here, which is my long side. I know my long side, my apothem, is equal to my short side times the square root of 3. So 3.5 square roots of 3 is the apothem. So I'm just going to plug all of that in. So I get area is equal to 1/2 times apothem, 3.5 square roots of 3, times perimeter, 42. I'm just going to put that in my calculator. I'm going to say 1/2 times 3.5 times 42, and then just add the square root of 3 there. So half of 42 is 21, and 21 times 3.5 is 73.5. I didn't really leave enough room right there. Let's try that again. 73.5 square roots of 3, and my units are centimeters squared. All right, number 15. All right, 15 says find the area of an equilateral triangle with radius of 8 square roots of 3. So draw out this equilateral triangle. It says with radius, so here's my center, drawing my radius in here. I have 8 square roots of 3. And that's horrible. Let's try that again. Okay, so there's 8 square roots of 3. If I drop my apothem right here, then I have a 90-degree angle. I know that each of my angles, well, I could say 360 divided by 3 to find my central angle of 120. I could divide that by 2 to find this angle right here to be 60. So this angle in here is 60. And then it's a 90-degree angle, so that makes this angle right here 30. So I really have a 30, 60, 90 triangle. If I want to find the area, I need to find I need to find the side, and I need to find the apothem. Well, my apothem is across from the 30 degrees. So that's my side. And I know that, so area is equal to the short side. I guess I should clarify. And I know the short side is always half the hypotenuse. So right away I know my apothem is half of 8 square roots of 3. So my apothem is 4 square roots of 3. Then I know my long side, I'll call this S, my long side is my short side times the square root of 3. So my short side's 4 square roots of 3, then times square roots of 3. So it's really 4 times 3, which is 12. Well, that's just half of my whole side, because that's what this is right here. I need the whole side. So the whole side then, if I times that by 2, is really 24. And then there's really 3 sides, so 24 times my 3 sides, and I get 72. So that's my perimeter. So now I have, let's see, I have my perimeter, I have my apothem, and I can just plug it in now. So area equals 1/2 the apothem, 4 square roots of 3, times your perimeter, 72. So area is equal to, well, half of 4 is 2, 2 times 72 is 144 square roots of 3. And this is meters squared. Now on the test, if you don't remember these 30, 60, 90 special right triangles, well, 1, it's going to be on the board, so you could always look up there. But 2, you're just maybe so used to using trig. If your answer is in a square root, just put this in your calculator, 144 times the square root of 3, and get it as a decimal. And whichever answer matches your decimal form would be the right answer. So it's okay if you're using trig to solve these problems. Alright, number 16. It says a regular hexagon has a perimeter of 50 meters. Find its area. Leave your answer in simplest radical form. So again, we want this simplest radical form. So I'm going to draw my triangle that we get out of our hexagon shape. And we know that this angle right here is half of our central angle. So we'll say 360 divided by 6 since it's a hexagon. And we get 60, and then half of 60 is 30. So I know right here this is 30. So again, we have a 30, 60, 90 triangle. It says the perimeter is 50. So if the perimeter is 50, I can plug that into my formula. A equals 1/2 the apothem times the perimeter, which is 50. But also, I could say 50 divided by 6, since there's 6 sides. And then this, whatever I get here, I could also divide it by 2. I'm going to divide this by 2 again to see just what this little side is right here. Well, when you have a fraction and you're dividing it by a number, you really are multiplying by the reciprocal, right? So by 1 over 2, so it's really 50 over 12. So that's what I'm going to say this is right here, 50 over 12. Alright, so this is what our short side is since it's across from the 30-degree angle. So our apothem here is our long side, and we know our long side is just the short side times the square root of 3. So our apothem is just 50 square roots of 3 over 12. So I'm just going to plug this in now. So area is equal to 1/2 apothem, 50 square roots of 3 over 12 times 50. And yeah, this is pretty ugly. It's a mess. Area is equal to, so if I made everything a fraction, put this 50 over 1, then I say 1 times 50 times 50, so I get 2,500 square roots of 3 over 2 times 12 times 1, so over 24. That's 24. And then I just want to reduce that. So reducing that, I get, if I divide, I could divide the top by 4 and the bottom by 4. So my area is equal to 625 over 6. And this is times the square root of 3. And we are using meters, so meters squared. So this is my final answer. Alright, number 17 says the figures are similar. Give the ratio of the perimeters and the ratio of the areas of the first figure to the second. The figures are not drawn to scale. So first to second. So 18 over 16. And we can reduce that. We can divide both of them, let's see, just by 2, I guess. So we get 9 over 8. So this is for perimeters. This is the ratio of the perimeters. To find the ratio of the areas, I'm just going to square it. So 9 squared over 8 squared. So I get 81 over 64. And here's my ratio of the areas. So simple enough. Here's my 2 answers. For the perimeters, for the areas. Looking at number 18. It says find the ratio of the perimeter of the larger rectangle to the perimeter of the smaller rectangle. Okay, so the larger one, we see we could use either sides here. It's giving us 2 sides to choose from. We have the 4 of the larger one or the 12. It doesn't matter which one we use as long as we use the corresponding side for the smaller one. So I'm going to go with the smaller side so I don't have to reduce. So I'm going to forget about the 12 and forget about the 9. I'm going to say 4 over 3. Since these are the corresponding ones, and you can't reduce that. So here's our answer. Alright, 19 says the trapezoids are similar. The area of the smaller trapezoid is 131. Find the area of the larger trapezoid to the nearest whole number. Alright, so I'm going to find my perimeter ratio first. So I'm going to say 12 over 64. And when I reduce that, they're both divisible by 4, so I get 3 over 1 and 6. So 3 over 16. To find the area of the larger trapezoid, I now need to find the area ratio, because this is just the perimeter ratio. So I'm going to take this and I'm going to square it, and I get 9 over 256. So I'm going to set that, 9 over 256, my area ratio, equal, I'm going to set up a proportion. I'm going to say it's equal to 131, since that's the area of the smaller trapezoid, over x, the area of the larger trapezoid, what I want to find. And now I'm just going to cross multiply. So cross multiply, I get 9x is equal to 256 times 131. Go ahead and put that in your calculator, and you get, wow, you get 33,136. And then when you divide that by 9 and you divide that by 9, you find the area of the larger trapezoid to be 3,726 meters squared. So here's your answer. Number 20 says, Hiram raises earthworms. In a square of compost 4 feet by 4 feet, he can have 1,000 earthworms. How many earthworms can he have if his square of compost has a side length that is 5 times longer? Okay, so what we're basically doing here is finding the area, the ratio of the area, and then setting up a proportion again. So originally it's 4 by 4, so we have 4 over, and then the new one, if he has one that's 5 times longer, well, 5 times 4, that would be 20. So when we reduce this, we get 1 over 5. So this is our perimeter ratio. Again, if we square both top and bottom, we're going to get the area ratio, which is 1 over 25. And we can use this 1 over 25 to set up a proportion. So 1 over 25 is equal to, well, in the 4 feet by 4 feet, he can have 1,000 earthworms. And we want to know how many he can have in the larger one. So we'll put that over x. So when we cross multiply, 1 times x is just x, and 25 times 1,000 is 25,000. So he can have 25,000 earthworms if he makes a 5 times longer one earthworms. All right. Number 21 says 2 trapezoids have areas of 432 centimeters squared and 48 centimeters squared. Find their ratio of similarity. Now remember that ratio of similarity is the same thing as the perimeter ratio. So that's what we're trying to find. So we're going to say 432, since that was the first number given, over 48. And we're just going to reduce this first. Let's see, I can divide the top. I can definitely divide the top by 4, and same with the bottom. So that's 108 over 12. And I can divide the top again by, well, definitely again by 4. So I get 27 over 3. And again, I could divide both of these by 3. So I get 9 over 1. Okay, so this is their area ratio. So if I take the square root of both top and bottom, I would find the perimeter ratio, and I get 3 over 1. So this is their ratio of similarity. Alright, this one says find the area of the regular polygon. So again, area for a regular polygon is equal to 1/2 apothem times perimeter. It says give the answer to the nearest tenth. So we have a pentagon, that's 5 sides, with a side of 8 feet. So right away I know my perimeter is 5 times 8, so my perimeter is 40 feet. So I could plug that in right away. Then to find my apothem, I need to say 360 divided by 5, since there's 5 sides. I get 72. I'll divide that by 2 to get 36. So this is the angle. If I were to draw this triangle, that would be this angle right here, so 36. I know my side on the bottom is 1/2 of 8, so down here this is just 4, and I want to find my apothem, A. So I'm going to use my tangent function because I have opposite, and I'm trying to find adjacent. Opposite the angle, and then adjacent to the angle. So I'm going to say tangent of 36 is equal to 4 over A. And to solve for A, I'm just going to switch the tangent 36 and A and get 4 over tangent of 36. And I'm going to take this and I'm going to plug it into my formula. I'm going to take the 40 feet, plug that into my formula, and I'm going to solve. So area is equal to 1/2 apothem 4 over tangent of 36 times my perimeter 40. I'm going to put all that in my calculator, and I'm going to get that my area is equal to 110.1, since I'm rounding to the nearest tenth, and this is feet squared. Alright, number 23 says the refs are planning to buy an above-ground swimming pool shaped as a regular octagon. So that's 8 sides. The radius of the octagon is 9 feet. To the nearest tenth, find the area of the surface of the water in the pool. So again, we're just finding the area. So we know nothing right away because it gives us the radius. But we can say 360 divided by 8 is 45, divided by 2 is 22.5. And this is our half of our central angle. So when I draw that triangle, this is 22.5 in here. That's horrible. So this angle is 22.5. I know my radius, it says, is 9. I need to find this side and this apothem. So I'm going to use a few different trig functions. To find the apothem, I'm going to say cosine of 22.5 is equal to a over 9. So a is just 9 cosine of 22.5. That's my apothem. To find my side, I'm going to use sine. I'm going to say sine of 22.5 is equal to the side over 9. And again, I'll multiply both sides by 9, so 9 sine of 22.5 is equal to the side. Now you have to remember, that side, though, is only half of the whole thing, so I'm going to times it by 2. And then there's 8 sides, so I'm going to times that by 8. So really, my perimeter is equal to, well, 8 times 9 is 72, and 72 times 2 is 144 sine of 22.5. So when I plug this into my formula, I'm plugging in area and perimeter. I'm sorry, this was apothem times perimeter. So area is equal to 1/2 apothem, 9 cosine of 22.5 times perimeter, 144 sine of 22.5. And when I put that all in my calculator and I find the area to the nearest tenth, I get that my area is equal to 228.7, and we're using feet squared. So here's my answer. Alright, last two problems. 24 says two triangles each have adjacent sides of length 120 feet and 180 feet. The first triangle has an angle between the two sides of 40 degrees, while the second triangle has an angle between the two sides of 60 degrees. Okay, so maybe we should start drawing these triangles. So it says 120 by 180. And it says the first triangle has an angle between them of 40. Then we have another one that is 60. Oh, 1 second. Alright, sorry about that. So here's our other triangle. And again, 120 and 180. So it says, what is the approximate difference between the areas of these two triangles? So I just need to set up the formula for area of both of these and subtract them. So the area for this first triangle is 1/2 times, make it a little bit smaller, 1/2 times 120 times 180 times the sine of 40. And I'm going to take all of this and subtract the area of the second triangle. So 1/2 times 120 times 180 times sine of 60. And when I put all of that into my calculator, I see that the approximate difference is 2,411 feet squared. Alright, number 25. Find the area of the triangle. Give the answer to the nearest tenth. Alright, so we're using the same formula as above. So the last one's a pretty easy one. 1/2 times the side, 12, times the other side, 7, times the sine of the angle, sine of 84. And when you put that in your calculator, you get, rounding it to the nearest tenth, 41.8 centimeters squared. Alright, you guys, if you watch this video from the beginning to the end, it's a pretty long video. Thanks for hanging in there with me. We have a test tomorrow. Bring your learning objectives, bring a calculator, be ready to go. Any late work too. Bye, you guys.